Lesson 4.2, Greatest Common Factor. A common factor is a whole number that is a factor of two or more non-zero whole numbers. An example of this is the number 12 and 24. They both can divide by 2. That could be a common factor. Or 4, 6. Those are common factors. The greatest common factor is the greatest of the common factors. In the case of 12 and 24, it would be 12. That would be the greatest common factor, or we call it the GCF. Relatively prime means that two numbers that have the greatest common factor of 1. So the only thing they have in common is the number 1. Example 1. A high school asks for volunteers to help clean up local highways on one Saturday each month. The group of volunteers has 27 freshmen, 18 sophomores, 36 juniors, and 45 seniors. What is the greatest number of groups that can be formed if each group is to have the same number of each type of student? So how many freshmen, sophomores, juniors, and seniors will be in each group? There's two methods to solve this. You can list the factors of each number. And remember, we do that by going 1, 27, 3, 9, and so on. $18 is 1, 2, 3, 6, 9, 18. 36, 1, 2, 3, 4, 6, 9, 12, 18, 36. And 45 is 1, 3, 5, 9, 15, and 45. If you look at these lists, what is the greatest number that is on every list? Here's a 9, here's a 9, here's a 9. 9, I would say, is the greatest common factor. The common factors are 1, 3, and 9, but 9 is the greatest. The second method is to write the prime factorization of each number. The GCF is the product, so when you multiply all of the prime factors. Let's talk about that. 27, factor tree, 3 and 9. 9 becomes 3 and 3. So you have 3 times 3 times 3. 18, I can do a couple of things. 2 and 9, which is 3 and 3. So I have 2, 3, 3. 36, 6 and 6, which becomes 2 and 3, 2 and 3. So I have 2 times 2 times 3 times 3. And 45, which is 5 and 9. 5's prime, 9 becomes 3 and 3. So you have 3 times 3 times 5. Look at the common primes. Which ones are on every list? You can see there is a 3 here, 3 here, and a 3 here, and 1 here. So they're all in common. There's actually another 3 in every list. And I think that's it. So 3 and 3. So when you multiply 3 times 3, the greatest common factor is 9. So 9, the greatest number of groups that can be formed is 9. That means if you take 27 divided by 9, you have 3 freshmen, because there was 27 freshmen. 18 sophomores, so divide by 9, you have 2 sophomores. 36 divided by 9, and you have 4 juniors. And 45 divided by 9, 5 seniors in each group. Find the greatest common factors of the numbers. I prefer the method with the prime factorization because I think it's quicker than listing everything out. Plus, when you list the factors, you may forget them. I'm going to show you how to do it again with number 1. 54 is 6 and 9, which becomes 2 and 3. Then this is 3 and 3. So you have a 2 times 3 times 3 times 3. 81 is 9 and 9, which becomes 3 times 3 and 3 times 3. So you have 3, and actually you could list them on in a same column like so you can kind of see what's in common. You can see these 3's right here are in the same row. So 3 times 3 times 3 equals 27, because 9 times 3 is 27. That's the greatest common factor. Try number 2. Pause the video. 12, let's do the factor tree method. Again, I prefer this way. Your listing can just get very tricky. And then I'm going to put my 2 times 2 times 3. I'm going to make a big list. 48 was 12 and 4. 6 and 2. And that 4 became 2 and 2. This is 2 and 3. So we have a 2 times 2. We actually have a 3. I used 1, 2. I need 2 more 2's. 1, 2, 3, 4 2's and a 3. 66, 11 and 6, which is 2 and 3. So you have a 2 and a 3 and an 11. You can see these are in common. So you have a 2 and a 3 in common, and 2 times 3 is 6. That's the greatest common factor. Find the greatest common factor of the numbers. Tell whether the numbers are relatively prime. Okay, we can list the factors of each number and identify the greatest number that the lists have in common. So we have 1, 2, 4, 7, 14, and 28 for the factors of 28. The factors of 63 are 1, 3, 7, 9, 21, and 63. Well, I see that the 7's are in common, also the 1's, but the 7 is the greatest, so I'm going to say the GCF is 7. They are not relatively prime then. To be relatively prime, the only thing in common is 1. Let's try 42 and 55. This time we're going to do the prime factorization. So we're making a factor tree. Anytime it says prime factorization, you need to think about doing a factor tree. (42) is 6 and 7, which becomes 2 and 3. So you have 2 times 3 times 7. 55 is 11 and 5, which is 11 times 5. You can see that nothing is in common. If nothing is in common, then the only thing they have in common is 1. I know you don't see that in the list because these aren't lists. These are factor trees or the prime factorization. So you're not going to have 1, but 1 is the only thing in common. So the numbers are relatively prime. Find the GCF of these numbers. Tell whether they are relatively prime or not. Again, I'm going to try the prime factorization way. You can try to pause the video and try yourself. If you need help with the first one, I can show you through the first one. 10 times 3 becomes 5 and 2. So we have a 2 times 3 times 5. 49 is 7 and 7. So we have a 7 and a 7. Well, nothing's in common. So the only thing in common is 1. Yes, they are relatively prime. You might even want to put RP for relatively prime, indicate somewhere that it is relatively prime. Pause the video and try number 4 now by yourself. (52) can be divided by, well, you know it's even, so you can divide by 2. 2 is prime. 26 can divide by 13 and 2, and that's what you have. 2 times 2 times 13. 78, again, you have, it's an even number, so you can divide by 2. You have 39. 2 is prime. Again, you can circle the primes. 39 can divide by something. It actually divides by 3 and 13. So for 78, if you need to, you can write out what they are. 78 equals 2 times 3 times 13. What's in common? These 2's and the 13's. So 2 times 13 is going to get you 26. It is not relatively prime. Let's find the GCF of monomials. To find the GCF of monomials, we factor the monomials. Remember that equals, or that means to expand the monomials. So let's do the factor tree for 16. 4 and 4, which is 2 and 2, 2 and 2. So you have 2 times 2 times 2 times 2. Expand the x squared, which is 2 x's and a y. 26 is 13 and 2. And that's it, because 13 is prime. X times y times y times y. What is in common? These 2's are in common. These 2 x's are in common. And 1 y. So you have 2 x squared times y. That is the GCF. Go ahead and find the greatest common factor of these monomials. Remember to expand, we call it factoring. Okay, remember we call it factoring the monomials or expanding the monomials. Pause the video and try 5 and 6. Number 5, this becomes 3 and 4, which is 2 and 2. So you expand 12x cubed, 2 times 2 times 3, and 3 x's. 18 is 6 and 3, which becomes 2 and 3. So 2 times 3 times 3, and then 2 x's. What's in common? 1, 2, 1, 3, 2 x's. Multiply those together, you got 6 and x squared. 40 is 10 and 4. 10 becomes 5 and 2. 4 becomes 2 and 2. So you have 2 times 2 times 2 times 5, an x, and 3 y's. Remember, expand out the variables. 24 a couple of ways. 12 times 2, 6 times 2, and 2 times 3. And again, make sure you have all the 2's. So you have 3 2's, and a 3, 1x, 1 y. What's in common? 3 2's, an x, and a y. So 2 times 2 times 2 is 8xy.